Okay, and I should share my screen. Fixing the stream. Okay, so all right, so I'm here to tell you about what is going on with TorchRec DLRM tracing. And so just as a brief reminder, so our goal here is, hey, PyTorch 2 is cool, but we can't run it on our internal AS models because they have sparse architectures, which involve KJTs and random stuff. So can we actually compile it all the way through? And as a proxy for this, and something I can actually talk about in this public meeting, we're going to do TorchRec DLRM. And we're going to do it with distributed and with sharding. And so yesterday I got it to work all the way through. So what does that mean? So it means that I can take DLRM, I can run it on 2 nodes, I can torch compile on each node separately. They're doing all-to-all communications to farm out the embedding lookups, and it runs all the way through in PyTorch 2 using only using Dynamo Eager. So I didn't actually test AOT Autograd. That's a good thing to try next afterwards. And so yeah, that's cool. I did a lot of stuff to make it happen, but it is nice to know that it is actually possible to do this. So what was the big delta from the last time I've told folks about this? So the big problem that I was blocked on before is that in TorchRec, they have these custom autograd functions for doing their all-to-all communication. And they're written in a strange way. So normally the way you would write an autograd function is you would write your forwards and you write your backwards. But actually the TorchRec autograd functions are written as 2 functions, a request function and a wait function. And the autograd functions themselves return these input dummy tensors. They don't do anything special. And the reason they do this is because they want to be able to trigger the all-to-all communication asynchronously. So they want to launch the all-to-all and then do some other stuff, and then later, when they actually need it, wait on the result. And only then do you actually block waiting for the communication to finish. So, there's no way to do this in like a traditional custom autograd function all in one go, because most of PyTorch is written synchronously. So that's why they have to split it up into 2 autograd functions. So this is pretty hard for Dynamo to deal with for a number of reasons. And the way we unblocked it was just by rewriting the autograd function so that it was actually just written in a synchronous fashion, 1 autograd function. That's good enough to get. I actually had to allow and graph it in the end, but that was good enough to get things going. Thanks to Vaz for convincing me that this actually would be possible, because last week I was like, I don't think this is possible, but actually it is possible. Yeah, so that's pretty cool. Questions, comments? Okay, let me talk about what is next. So what is next? So there's a lot of stuff that still needs to be done. So obviously, all I've done is I've hacked up TorchRec and FBGem and PyTorch so that this actually works. So, this wouldn't work if you actually tried it on main. So the big pile of stuff we need to do. There's a big pile of Dynamo fixes that are various bugs that we ran into. By the magic of open source, thank you, John Chuang, if you are listening in. Many of these issues have been fixed. There's still a bunch more that need to get fixed. These are not too big of a deal. They, just someone needs to look at them and figure them out. One of them that's particularly annoying is there is a sort of minor disaster going on with allowed functions in Dynamo and distributed tracing, where it's basically very difficult to convince Dynamo to actually inline through functions that live in Torch namespace for hilarious and difficult to understand reasons. So this was one of the topics I brought up, but we're not going to talk about it. But there is a plan in the works for how to do this in Dynamo, but it is pretty confusing. And if you've ever worked on Dynamo and distributed and you're like, oh, this is terrible, please let us know, because we think we can help. There's some more foundational stuff going on here. So CUDA streams actually isn't too bad. Am I just ignoring it? No, we're not really using CUDA streams in an interesting way. There's some stuff that I found out a long time ago that still needs to be done, Like for example, FEGEM has these bound checks on indices operators that need to not get DCE'd when you run AOT autograd. So something needs to be happening like that. We need to figure out what the permanent strategy for the synchronous autograd functions is. So obviously rewriting the autograd function works, but that leads to a lot of code duplication. So I don't know. If I were the TorchRec devs, I would not like this code duplication. Dennis said that we should talk about it at PyTorch conference next week. So that's my plan. I'm going to talk to Dennis some more and try to negotiate what exactly we're going to do. And in general, because our staging strategy is when you have async code in forwards, we want to turn it into sync code for our compiler backend, because we're going to assume our compiler can handle things synchronously. We need to like do this. So there's some easy stuff like rewriting all-to-all single into synchronous collective. Vaz showed me how to do that yesterday, so that just needs to be done. And then a bunch of other stuff. There are a big pile of FEGen functions that need metas that I've like written half-baked versions of in my branch, and these need to get upstreamed. And yeah, I mean, looks pretty good. And so the next step is that we need to get AOT autograd working with this, and we need to get inductor working with this, because most people want to actually run with inductor optimizations in this situation. Okay, any more questions, comments? Yes, Will.
I guess I'm wondering if the futures idea took off, if anyone's working on that, would that also be an option
I
here?
verified it's running on extra torch.
Martin, please mute.
Yeah, let me know if I missed anything. And hand checking is also.
Can I mute him? I can't mute him. Lol.
Oh, sorry, I didn't.
Okay, never mind. I was wondering.
Yeah. So your question was about futures. So I had a discussion with Will Feng about futures, and I don't know if it's like rolled over to everyone else. Is Will here? No.
Yeah, I'm here.
Oh, you're here. Okay. Yeah. Can you answer Will's question?
Yeah. I think after discussion with Ed Tuesday, and also discussion with Horace later on that day, I have a better proposal for futures. Basically we're taking like a static schedule to the scheduler, and then the scheduler would just for each ops that comes in, check against the schedule to see if it matches the schedule, and if yes, then executes it. If not, then just not execute the op until at the very end. I believe this will work. I just like need maybe some more time to like run out the prototype. But so I think at the beginning I was thinking, oh, let's just like pull the queue to see what op we can run, and then run it like to like in other words, to schedule the ops dynamically. But I think to just follow a static schedule to start makes more sense, and it will also adjust like the overhead concerns of scheduling ops.
Will, did that answer your question?
Yeah, I mean, I guess like the other side of the question would be just, could we use futures for TorchRec? Could we start issuing futures instead of using the work.wait concept, and then like you wouldn't have to do this rewriting?
So that's one of the things that I do want to talk to Dennis about. So let me just make sure I understand your proposal correctly. So concretely, what you're saying is, instead of explicitly doing future, well, so one thing is that TorchRec kind of has futures, right? Like, let me see. Can I show you some code? Let's look at here. So if you just look at the code prior to my change, right? What TorchRec has is, it does the all-to-all single, giving you the request object, and then it stashes it so that later, when you are running the backwards, you can go ahead and wait on it. So like,
but like the problem is we can't trace that form of the API, so we need to convert it to a synchronous call. And then I guess instead of doing that, we could just have TorchRec change to explicitly use a future if a future is a traceable concept from the beginning. That's my proposal.
So okay, so one quick question. So when you say use future, does the code look synchronous or asynchronous now?
The code with a future would look asynchronous. You'd create a future that would kick off the op, and then you'd wait on the future.
Okay, so one thing I want to mention is I don't think that actually makes our job easier on the Dynamo side, because I still have to like split the autograd function so that the future shows up. So okay, there's two problems. So one is that if I just use futures in forward, I think, well, you're telling me that futures are traceable in forward, so that's fine. But then there's a second problem, which is that we also have these custom autograd functions, and the futures need to flow through the custom autograd functions, and that's not so easy to actually do, because our autograd function support is very limited. Like there's only a limited set of things you can actually pass from forward to backwards. Voss.
Okay.
One thing I keep failing to understand with our futures designs, is this a new user-facing structure that like users actually author things like algorithms and models with features in place of tensors or wrapping tensors? Or is this a purely internal notion where we like identify certain things and turn them into futures?
I mean, we're talking about a very specific thing, right? This guy,
Yeah.
right?
I just don't understand how, like, is this a new user-facing construct?
So I think there is a way to do that without a new user-facing construct, or at least that's where I want to get to, because otherwise there is a user learning cost of like having to introduce a new user-facing thing. I believe there is a way to just to have futures be like a runtime thing. For example, like in the forward, like the result of the request is like a future tensor, and then in the backward, like when we need to consume it, we implicitly, for example, call wait on it, or have the scheduler be scheduling it to be earlier than the consumption point, and then at the consumption point we already have the value ready.
I guess then now I don't understand why we even need this. Like, how is that any different than just like inserting the right ops into the graph? If you can already identify all those things to do it at runtime, why do you even need a futures construct?
So you need something that actually triggers the prefetch. And so with Will's thing, it's this implicit scheduler that has a static schedule that's like, when, you know, I've gotten to this part in the operator stream, I'm going to kick this thing off so it is ready when you need it later. But Will, your thing is very implicit, right? I don't actually have to change my code to use your scheduler.
That's right. Yeah.
Whereas Will Constable, I think you're talking about something different. You're like, what if I just write my code asynchronously with explicit futures? And as long as you use the traceable future concept, which exists in PyTorch today, then we would be able to trace through it. Okay, can we get some clarity in this meeting? Like, Will, are you working on this futures thing or not really?
I'm
sorry.
working
Yeah, confusion. Will Constable, are you working on your futures thing?
Oh no, I'm not working on any future thing. I was just trying to catch up on what's going on with futures.
Okay, so Will Feng, you're the only one who's actually working on the. I don't even want to call your thing futures. Can we call your thing the scheduler?
Sure. Yeah.
Okay, we're
works.
calling Will's thing the scheduler. Okay, so absent people being like, no, Will Feng, you should work on something else. Person writing the code, you know, has dibs. So I would like the plan on record as registered in this meeting to be, we're looking into having an implicit scheduler that knows to start running things like early, but doesn't require user code modification. So user code is still written synchronously. Voz?
Yeah. One super quick question. If the schedule is static, does it need to be a runtime thing? Can you just reorder the inductor graph or the graph before inductor and treat it like that, and then you don't have any runtime anything. There's just your static order is explicitly produced.
Will? Did we lose Will?
Yeah, let me see. So I think the schedule captures so the schedule like global schedule across all graphs. And it also have graph breaks inside. So like when there's a graph break, the schedule need to like make sure there's a graph break when it expects a graph break, basically.
Well, let me try to
I don't
restate
know
what
if
you're
that
saying.
answers the question.
Your scheduler works in eager mode, and it works in PD2 where there are graph breaks. And those graph breaks can also include cross-iteration breaks.
Yes, that's right.
So, Vaz, does that answer your question?
Yeah, that's a good answer. Thank you.
Okay. One last thing. So if we like do Will's plan, then I suppose hypothetically you could imagine a situation where TorchRec uses the implicit scheduler and they can write their code synchronously and the prefetching, manages to happen ahead of time. Now, whether or not TorchRec actually wants to do that, I'm not sure, because it's kind of weird, right? Like you had code that already manually did all the prefetching. So why would you like undo it? It's just so that some compiler could get it wrong, right? And it's going to get it wrong until, you fix all the bugs. But like hypothetically, that would be also a coherent strategy and would leave you with only one version of the code. Okay, is there anything else people want to talk about here? Okay, well, let's keep talking about distributed. So Will Constable, can you tell us about what's going on with compiled autograd?
Sure. So I dragged Chin over here too, and I'm mostly flagging something like it came up last week at the end of the week. We thought that we might need compiled autograd after all for compiled DDP, and we're not sure about compiled FSDP. So I think Chin still has some outstanding experiments to try Vaz's branch with backward hooks and see like how it behaves for FSDP and DDP. But that being said, I think the TLDR is that we're not sure if we can get the all reduces to overlap with compute in
without
compiled autograd, and for the DDP case. And I also have the same question about FSDP for reduced scatters. Can we get them to overlap? Because there's been some kind of back and forth on like, we don't really need compiled autograd for these things, but we do need the overlap. And so I'm wondering if we need compiled autograd.
Vaz, can you tell the room about FSDP?
Yes. Should I just start from the top?
No. I just so Will has a question, which is, does FSDP need compiled autograd? Can you answer that question?
Yeah, it's commented. The compiled autograd check is commented out right now on the branch, but directionally it does. It does because register hooks. So one second. So like, how should I frame this? No and yes. If you look at the contents of the backwards hooks in FSDP, we know everything that's happening in them. So we could always like kind of pretend that we're doing the right thing and actually simulate everything by hand. But in reality, backward hooks can have anything in them, and they run too late for us to be able to fully capture everything that's happening in them with regards to Python state during speculation. Autograd function backwards has this exact same problem, actually. And so what ends up happening is in a hypothetical situation is you have some backward hook that checks Python state for control flow or mutates Python state for some other system. You don't update it correctly because you've inlined through it and backwards. And then now things are just wrong. The way we've sort of come up with a plan to fix it is we have this higher order op that acts like an allowing graph that for AOT autograd. It bypasses it smuggles your function through AOT autograd, and then when you run compiled autograd, you trace through the hook call as a call hook, and then Dynamo re-enters it when compiled autograd calls Dynamo. So you're dynamoing the contents of that hook. And that is why we need compiled autograd, because if you don't have it running, then the contents of your hook will get installed as either this hop, which then will be incorrectly run without Dynamo, or if you skip the hop thing and you just naively register the user provided callable as a hook, then AOT autograd will inline it, take out all the ops, turn them into A10 ops, take out all the compute stuff, and then all your Python state mutation and checking is lost. And so we haven't come up with a better way of sort of protecting that user defined function in backwards other than compiled autograd.
Okay, Will, did that answer your question?
I'm not gonna lie, I got lost halfway through. But
let me try to restate. So essentially, what Voz is saying is that with FSDP, if we don't have compiled autograd, we are unable to induct or compile FSDPs backwards.
Yes.
I mean, that's a simple answer. I thought Voz was trying to say that we could do it in some hacky way, but I don't even know if I understand how the hacky way would work. But yeah, if we're saying we just can't do it, that makes me happy. I think we just need to agree that we use compiled autograd and then make it safe.
The hacky way is not something that I think we should do, but it would be possible. Let's say we couldn't get this right at all. We know we own the backwards hook in FSTP. We know the Python state it mutates. It like does bookkeeping to see what's run and what hasn't run with regards to hooks. You could totally just like fake simulate that and have like a bunch of contextual stuff you like lift into globals and manage on behalf of that, and to make sure that the code that's like running through trace produces the right thing. But like that's a huge pain in the butt. It doesn't solve anything generally, and it's brittle because then if somebody changes FSTP backwards behaviors, you kind of have to go and update Dynamo and teach it about all those little like bools and stuff it sets, and we don't want to do that.
Okay. I do think it's a good idea to make a decision here, partly just for staffing and planning. Like, I think if we say that we can somehow work around this, that might just result in delaying prioritizing compiled autograd.
Okay, so let me just, I'm gonna butt in. Okay, so compiled autograd is a key part of FSDP, and now Will Constable is telling us as well it is also a key part of DDP. So we will make sure it is staffed appropriately. So we being
Sure,
the royal cloud.
I just want to add another thing. Like, even with like a hacky way, I actually don't see how you can do compiled DDP without compiled autograd. Like, even if you just assume the hooks are traceable, like the original reason, or like one of the original reasons compiled autograd was developed in the first place, is for the issue that you don't know when your hooks are going to be triggered, which makes it very difficult to inline, right? Like,
so Horace, to clarify, you're talking about the hooks on parameters.
Yeah.
Accumulate grad hooks, I think, right?
Accumulate grad hooks.
Yes.
Yeah. Accumulate grad hooks are a whole other thing also.
Yeah, so I agree with Horace. Like, so actually, the sort of reasoning that's going on here is kind of different between FSDP and DDP. Where for FSDP it is this hack could work, but for DDP it just doesn't work. But the thing about accumulate grad is exactly what compiled autograd was designed to solve. So like, Jason Ansel isn't here, but Jason Ansel has been like giving us bug fixes for compiled autograd for FSDP, and so I think if you talk to him on DDP stuff, that should also like be fair game as well.
Yeah, happy to talk about the DDP stuff.
Okay, we good with this topic?
Yep.
All right, moving on. So I think next we're going to grill some export side effects. So Tugsu, please tell us why this is hard.
Yeah, so originally we decided to if an exporter tracing a module where it modifies its attribute inside the forward method, we decided to not apply that while exporting. But we figured that it's actually pretty hard to do in Dynamo because how Dynamo works is that it applies the side effects on the fly. So next time when instruction translator reads the value, it expects to see like the updated value after the mutation. So if we simply just ban the side effect applying in export, it doesn't work because the next time you read it while exporting, you will see the alt value.
Sorry, I'm gonna interrupt. This just seems like the wrong way to implement it. like you should keep installing the side effects in the side effect data structure, and then when you're done, you should just like be like, okay, you have a bunch of side effects. I'm not going to actually run them.
No, but I think you need to apply those so that the next time when you read the value, you need to see
No,
that
no,
the
that's what I'm saying. Like you should still like update all the side effects data structures that are keeping track of what the mutations are. I'm just saying that at the end you'll have an FX graph, which is what you want, and then you'll have a bunch of side effects that we were originally going to replay as residual bytecode instructions, and you just toss it out. You just are like, I don't care about it. Like that stuff you asked me to ignore.
But wouldn't that happen on the fly? So like, let's say you modify self.b, right? So next time you read self.b, wouldn't that should be like the new value, right?
Yeah, so like the side effect data structure gets consulted like as you are like continuing to trace in Dynamo.
Yeah.
So that's why you do want to make sure you put the like for example, if I do a TX replace all, you should still do the TX replace all. If I like have a side effect and I like track it in the side effects object, I should still track it. So that if I query it later, I still see the side effects. The point is that at the very end is when you say, okay, and now I don't care, toss it all out. Voz, maybe you can explain it differently.
Yeah. Tuxu, the side effects are simulated, so you're not actually updating the real object. You're like updating our trackers for it. And so at the end, like imagine a world where you don't ban mutations. You've now have like your trace graph, but there's also some state that is like program state, like I don't know, a counter on a module that is different than when you started. You just need to be able to preserve that and pass it back to the user and go do whatever you want with it. They can apply it manually. They can like ignore it. They can do whatever. And I think that's what you're saying, right, Ed?
Yes. Okay. I think we should take this offline in that case. Tuxu, is there anything else you think we can usefully grill in this room? Jansel's here as well, but I think Jansel agrees with me and Voss.
Okay, so what if let's say we like inline set adder method, right? So in that case, like what should we do with the mutation? Because like the inlining would like basically essentially be another instruction translator, right?
You just run the instruction translator.
About the side effects.
I mean, these side effects are all accumulated in this one data structure. Like when you have a side effect during inlining, it's treated exactly the same as the side effect not during inlining. So like the semantics are like when you're Dynamo symbolic converting a function, no side effects happen, right? You queue up all the side effects because the side effects don't happen at compile time. The side effects need to happen every single time you call the function. So what we're doing is we're capturing an FX graph that has no side effects, and then we're generating bytecode that applies all the side effects at the end. And so if you want to like just throw out all the side effects, the thing you don't need to do anything along the way because you won't. Basically, the idea is that we compile the function once, and we're going to run it many times. And so if we were to do any side effects during compilation, that would be wrong because the side effect needs to happen every time, not during compile times.
I see. Makes sense.
Okay. So if you need more help, we're happy to chat. But this sounds like just it was implemented incorrectly, and that's why it didn't work. Okay. So is Ben here? Maybe not. Okay, we have no one on the Slim DSNN thing. The short version of this is essentially AOT inductor was originally scoped for CUDA inference primarily, but we've got some folks who are really interested in using it for CPU inference as well. So super like low latency model type situation. And so there are some design decisions that the AOT inductor team has made so far that are like not good for this super latency sensitive thing. So there's some, you know, renegotiation and timeline stuff because they're in a rush for how exactly this should go. Okay, so we've got.
I'm actually.
Go ahead.
I'm actually
Ben is here. Okay.
Yeah. I can briefly talk about it.
Why don't you give us a status update, because I don't think anyone on the other side of the wall is here in the meeting right now.
I see. Okay. Yeah. So as you said, those guys are working on this, applying this for CPU and on very tight timeline. So they're trying to beat the current solution, and which is through TVM. And the current status is they actually reached the goal, and it's actually performing better than the current solution. So the things they were sometimes with respect to the like design choices you were talking about, I think main thing they added was how to keep the output tensor unallocated. So basically they want to pass in that and hold on to that for during all the model running time. And it requires some changes to the current code gen. There are like longer term solutions we were discussing about, but it looks like they're already there, and we have more time to work on a proper solution for the long term one.
Peng.
Yeah, maybe I misread the post. I thought the shorter solution was like a handwritten C++ version. Did I get it wrong?
Oh, that's a separate project. Someone like from I think from the ads team is working on. So yeah, but that's not the one I was talking about. Yeah.
So you're saying right now AOT inductor is with some hacks is able to beat the TVM performance on Slim DNN.
Right. That's this morning's the data from BERT.
Oh, that's great. Thank you.
Okay, that's great. Thank you for the update. All right, so I now have a bunch of very small things with only one vote each. Jane, are you here?
Yeah, I'm here.
Yeah, I think your thing is of most general interest, so I want you to tell us about it.
Oh, okay. Cool. Should I share my screen as we walk through this?
Oh, yeah, sure. Go ahead.
Okay. This is to give people context as the screen is attempting to share and failing very hard to. Oh, there it is. Okay, nice. But many of you have been familiar with optimizers, but many of you have not been familiar with the confusing optimizer state dict. And a while ago, when people decided on optimizers, they were like, hey, we want optimizers to work even if NN modules got blasted off the earth. So we want them to be independent. And because of that, an optimizer should be able to take any sort of list or any sort of tensor. So like, because of this, because we were like, hey, let's keep them independent and take in any list of tensors, the state dict is thus very generic. I don't know if generic is the right term, but maybe just showing a sample state dict will do the job. So if you observe the state, we can ignore param groups for now. Those are all the hyperparameters. But for example, this is for something like SGD with momentum. Every state will contain an optimizer param key. So like if there are 4 optimizers, our parameters here are actually indexed by integers, which confuses people. But the reason for this is because we take in any list of tensors, so there's not necessarily a name to a parameter. And so every parameter key will be assigned to the state that's relevant. So in this case, the momentum buffer. And then in our param groups, if people specified a different, let's say, weight decay term, then we have params that associate with the param group they belong to. So if we want weight decay to not happen for the first parameter in our optimizer here, then we just say, hey, the key for which this applies is 0. And the key for which the other ones apply are 1, 2, and 3. Okay, I'm going to pause here, questions, jump in here. But I think there are a few glaring things about this optimizer state dict that already confuse people. One of them is like, if I'm trying to debug what's happening with my specific parameter, I now need to go through my list of parameters and match them. Like, oh, my first parameter is 0, my fourth parameter is 3, which is already a little confusing. Another thing is, notice that the state does not actually save the whole parameter itself. It does not save that tensor because we believe that the parameter is already saved elsewhere. So like, there's no need to duplicate saving that in terms of memory. And so general confusion aside, the reason this bubbled up to us and might be relevant to some folks is the fact that there are things like sharding and distributed, where instead of having one optimizer, you have multiple. So like, imagine having this optimizer, but like 8 times or however many times for the number of shards. Even if you're sharding across different parameters, the keys are still 0, 1, 2, 3, etc. for every single optimizer. So when you're reconciling that, well, sure. When you're reconciling the fact that you have multiple optimizers working on disjoint parameters, people had to basically create their own external mappings to be like, oh, like the 0th parameter in my first optimizer is actually linear 1.weight, and the 0th parameter of my second optimizer, that's actually like linear 25.weight. So things like keyed optimizer from TorchRec, named optimizer in distributed, and a bunch of other functions were written to just create this mapping. So if you're like, what is the ideal state dict? We're proposing a very simple one, or like the change from the previous one to the new one. It's just that instead of marking them with integers, we should give people the option to name their parameters. So like in this case, if somebody passes in this API, which is like model.named parameters, then we can preserve the names in the state dict so that when you do work on multiple optimizers of the same of disjoint parameters, or even if you don't do that, you'll get names in your state dict, which is, I hope, a lot more clear to anyone who's actually debugging with their state dict. Okay, pausing here to see if people here and have questions. Okay, great, no questions so far. Okay, so I guess the proposal, some of you were in the Optimizer 2.0 discussion we had about 2 weeks ago, and we have talked about PyTrees, so we can get into more of that later. But TLDR, I'm not gonna go with PyTrees just yet. The reason why we don't want to do that is because it's there's like unnecessary overhead that comes with it. And also when I talked to Chen, who I don't know if is on this call, and Iris, they were like, we just want flattened names. Like that is the best for DCP. That is the best for writing it into the databases where we store our state dicts. So because of that, and because people normally retrieve parameters through model.named parameters, and not like creating their own PyTree of parameters, I think the best way to allow the state dict to happen is to provide this API, which is for every constructor. Oh, okay. For every constructor, you can take in model.named parameters instead of just a list of tensors. And then everything else will stay the same. Cool. Do people have questions or concerns with this approach? Are there PyTree people who would want to argue otherwise?
Wait, sorry. So this is special case for named parameters?
This is, yeah. When you say special case, this is just like adding support for named parameters, but also anyone can just put in like an iterator of tuples if they wanted to not use named parameters, but name their parameters another way. Did that answer your question? I'm not sure if it did.
Yeah. I guess it does seem kind of awkward to me.
In what sense?
Or sorry, finding a room. But like I could imagine that, like, you know, like what do you do? For example, you have 2 modules that you want to optimize.
in that case, you would like concatenate your iterators or something. And then,
but how do you even concatenate your iterators then? Because like it's possible that your two modules may have like key conflicts.
okay, this is
Actually,
fair.
Jane, can I try to answer this? Because I thought the way we were going to do this is you would just have a dict, right, where it's like model 1, model 2 are the keys, and then you can just stick the named parameters.
Or no, Jane is saying that she doesn't want an arbitrary PyTree, just to like the proposal was to only support a tuple of name to parameters.
Oh,
was the proposal?
I must have.
Or like that was like the new proposal presented just now, I think.
Yeah. So like old proposal was like any arbitrary PyTree, but then like talking to people, they're like, we'd rather process a flattened version. So I was like, okay. And this is, this is not like set in stone or anything. So like, if in the way where there's two models, it could be possible to either like accept more than an iterator of tuples. You know, like it doesn't have to be an iterator of tuples every time. It could be a dictionary. It could be some other format. But I think getting to PyTree was a bit like any arbitrary PyTree was like very extra.
So why not just say it's a dict? Because like that gives us a path to like go to PyTrees later. Like, because if we just say it's like a 1-level dict, you're not allowed to nest dicts and dicts, then later on we could lift that restriction and like the API doesn't need to change. While like taking an iterator of tuples, like that sort of like locks us in to this specific flattening structure, and it sort of binds our hands later on.
Yeah, this is true. I am happy to. The reason I was like, oh, maybe it would just be sufficient to take in model.name parameters is because that's like a very easy API that already exists for people to just pipe into the optimizer. But you guys do bring good points where it's like, oh, what about like name collision? Do you err on that? And I think building a dict would naturally extend to PyTrees later. I did mention that. Like, one big reason for PyTrees is like figuring out our param group API, which right now is not a huge problem. But if we want it to be like a natural extension, I would agree with Jason that maybe accepting dictionaries would be like the natural first step to that world. So Jason, in your proposal, if I'm taking in a dictionary of, okay, I guess there are two proposals I'm hearing. Ed's proposal is like, hey, you have a dictionary where you name things and you have like a dictionary of dictionaries. But I think Jason's proposal is like, no, just like let people build and convert their name parameters to one single dictionary and pass that flattened dictionary in. And I am keen to accept Jason's one. Like, I think the flattened dictionary thing is more easy to understand and more universal. But I would love to hear other people's thoughts.
Sorry, I guess I kind of miss like why, like what's the reluctance against doing PyTrees? I didn't quite like the overhead to me seems relatively negligible, especially with like a C++ PyTree. And if you want to flatten it, you can just flatten the PyTree. So I guess it wasn't totally clear to me what the reluctance was here.
Okay, two parts. The first one is just like is like, how are we expecting users to create PyTrees? And if it's as chill as like, if we're accepting PyTrees very chill-y, like what Ed was saying with just like model to name parameters, that would be fine. But I was thinking, like when we were talking about this last time, it was like, oh, let's pass in state dicts, but the state dicts didn't have parameters. So like one reluctance towards PyTrees is just like, if we didn't have to get there, then there's no reason to like work out that PyTree API. The second thing is,
I do want like a PyTree is just like a nested data structure. It's not like a new. It's just like allowing like a nested data structure. It's not like a special concept that you have to have in like for the API.
Right. Yeah. Well. Okay. So like we could. Okay, I guess there are two reasons why. The first reason I just gave you, which was like, if it wasn't necessary, then like don't get into it. But it sounds like there are use cases. For example, if there are multiple models where PyTrees would be more useful. The second reason is like PyTrees felt like a bit underdeveloped in like processing PyTrees. If the internal optimizer would have to like depend on some sort of PyTree API, is there a very clear, consistent one that we are recommending for people to use today? Like, would it just be the Python one? I didn't want to like get into that unnecessarily.
The PyTree API is stable. The question is the implementation details are either in Python or C++. That won't change the public API of PyTree.
Okay. So we could depend on that. That changes.
You can depend on the API. It's just at the back end, like if it's slow or fast, that's what will change.
Okay. In that case, the other reason the PyTree API was like a little more, it's like non-trivial because then I think we would be forced to kind of rework our param group API. And we had done 2 proposals in our discussion. I think the one we ended up with are like having 2 sets of param groups essentially, which would be fine, but would be quite deviant from our current param group API. And of course, this is just to answer your question. Like that was the other reason why I was like, oh, why take that step if we didn't have to? Yeah.
I see.
But yeah, do people, like even now, I feel like I'm not entirely convinced we need PyTrees. Like I feel like a flattened dictionary, okay, well, I guess we could do both, right? Like flattened dictionary is like 0.5 step or first step, and then PyTrees could be next step.
Quick question. Wouldn't flattening a dictionary be as much work as creating an iterator of tuples? Like if the work you have to do to get a flat dictionary is the exact same work you have to do to get a single iterator of tuple strings. Because there's a one-to-one between a flat dictionary.
Or I think Jason's point, Jason's point was that like a flat dictionary is like compatible with a future PyTree-based approach, while a flat tuple of 2 elements is not compatible with a future PyTree-based semantics.
Yeah, a flat dictionary is just one level deep PyTree. It's a special case of a PyTree.
Also, there's the like making people make a dictionary where force their keys to be disjoint, whereas if we just like took in any iterator, there are key things that we would check.
Yeah. I would also mention that, as you were saying, like the other benefit of the tuple is that it exactly matches the current structure of the state dict we generate. If you take an arbitrary PyTree, the state dict we generate will need to be changed. And there are many downstream projects that assume that structure of our state dict. Like even just distributed checkpointing, FSDP checkpointing, all of these things assume this is the structure of our state dict. And changing these numerical IDs into single string, hopefully will not be too problematic for them.
This
should just work.
Yeah,
they will be happy with that change, and it should just work, even if they don't do anything. Going from matching 0 to 0 to matching linear 0 bias to linear 0 bias is good. But now if your state becomes arbitrarily nested data structure, I think it's going to be a lot trickier for them to deal with that.
I'm fine with like going to the dict as like step 1. And then in the future, because I agree, like things like resolving the param group API is like a separate discussion that's not requires a little bit more thinking.
Right. And I think to Albin's point, when I talk to checkpointing people, like this is something they already support. So like neither of this is PC breaking just because we don't accept something like this today. So like the state dict would be different. But this already works with most of like named optimizer, keyed optimizer users. So TorchRec and distributed would be happy with this change. But if we're adding more like layers of dictionaries or layers of anything here, I think it gets a lot more, like that would require changing DCP, would require actually like working with people to be like, now you have to take in this new state dict. So I think that's a pretty good reason to at least start with the keys being flattened and then working on that next.
I have one confusion, Jane, which is that I mean, it's not like everything is an improvement over the current state where it's like just 0, 1, 2, 3, 4, right? Like it's not like they actually have to do any extra work, right? Because they can always just ignore the keys and like do the manual matching that they used to do, right?
Well, like for like distributed checkpointing and
Well,
such?
no, so you're making some sort of like backwards compatibility argument where like, you know, most people can deal with single module like state dict FQN setup, but they can't deal with other things. But it's like they're not going to be able to take advantage of this logic without modifying their code anyway.
Well, okay, yeah, but the code modification is like delete some existing code they had written to get from this state dict to this other
Well, but
state
they
dict.
can't actually delete it, right? Because, you know, there's still going to be people using the old API, right? Just passing in parameters directly.
Yeah, but like, well, I guess my point is like for them to support this is as easy as. Actually, I don't even think they need to change much because they already taken things like keys optimizer, which looks like this. So like this already is supported. Whereas the new one with many layers, they would have to add like another code path for state dicts to go through.
Okay, that's all I wanted to say.
Does that make sense?
I did want to. Sorry, I did want to add like one more comment about like PyTrees and like whether they're necessary. Like in general, my feeling about like supporting PyTrees is like you can always ask like, is it really necessary for us to like support, you know, PyTrees here, or, you know, is a tuple or, you know, just one layer deep tuple or whatever is that sufficient? But I think in general, the main reason for like supporting PyTrees is just to be general and like not like solve this problem once and for all. Otherwise you'll like, you know, forever get people who have, you know, various cases that don't fit into your limited data structure. And in cases where I think that you can take PyTrees, I think it's generally just a good idea to support PyTrees.
Okay. I will keep that in mind. I still don't think we want to rehaul our param groups API just yet. Any other thoughts?
Yeah, I wanted to ask one question, which is like, you know, there's already some nested structure in the example you have, Jane, just because of the qualified names. So it's not really like PyTrees aren't necessary to represent nesting. You could add extra qualifiers to the names to disambiguate modules, say, or whatever else. So, you know, ultimately the decision about whether to structure your nested thing as a literal tree versus embedding that structure in the keys is sort of a separate decision to, you know, separate from whether you need a certain level of nesting at all, right?
Yeah, well, yeah, I think that's why I'm less inclined to jump directly to PyTrees, because it's already, like, I think this is what most people are used to, quote unquote, versus introducing like, oh, hey, everyone, we're gonna do PyTree stuff, which is easy for a lot of people. It's still like not the most straightforward, which is why it's like there's just like a tad overhead there.
Mm-hmm.
Just to give my support, I also support only doing a dict for now. Yeah, I think this is fine, and it doesn't cut off any future options.
Yeah. Okay. So I think I will actually, like, my final sentence is I will probably accept both this iterator and also a dictionary, because I think I want it. Well, actually, is it easy to just like turn this into a dictionary? Basically, I want to think if I'm a user and I just have one model and I just want to put it through optimizers with names, I just want to be able to pass model that name parameters, and allowing that seems useful, and allowing the, you know, combining a flattened dictionary also seems useful. So there shouldn't be any bad thing about supporting both. But if you have thoughts, please holler or like comment below if you didn't get to say stuff.
I think there is one downside, which is that the tuple structure is not PyTree compatible.
Oh, I see.
So so you would have permanently special cased this situation. Is there a reason why
the thing is,
state is bad?
the current API is not PyTree compatible either. You can already pass a dictionary with a bunch of stuff today, and that should not be interpreted as a PyTree. So,
Wait, sorry. What happens when I pass a dictionary today?
you can pass a dictionary of param groups today.
It's a list of dictionaries.
A list of dictionaries?
Yeah.
Okay. So I guess that's fine then. Sorry.
Okay, that's a good point. But yeah, okay, at the very least dictionaries, and then the secondary thing is if iterator tuple will make PyTree support in the future harder, then maybe not, but or special case it. But yeah, thank you for all your thoughts. Those were very good points.
Okay, thanks everyone. And that's all we have for today.